Godot 4 has finally reached beta and is inching towards an actual release. In addition to its numerous features and improvements, it can also automatically convert Godot 3 projects into Godot 4, so it's the perfect time to migrate existing projects. The conversion process isn't perfect, however, and it does require some manual labor, so in this video I'm going to show you how I migrated my third-person player controller to Godot 4. If you haven't downloaded Godot 4 already, there's a link to the primary mirror in the description box below. I start off by backing up my project just in case, and when I open it, Godot asks me whether to convert the full project or just the root project file. I choose full project and reopen it. First, I fix the sky material in the world environment node by setting it to a new procedural sky material. Next, I start fixing the sizes of some of the CSG nodes by resizing the ground mesh to 100 by 100 by 12, the platform mesh to 20 by 2 by 32, the boxes on the platform to 6 by 4 by 6, and the water bed for the pool to 24 by 10 by 16. To fix the lighting, I set the rotation of my directional light to something that looks good, and the scene lights up completely because in Godot 4 this procedural sky material determines the sun position by the direction of the directional light in your scene. To finish off, I set the pool waters material to a new standard material 3D with the transparency set to alpha, shading set to unshaded, and albedo set to a light blue with an alpha value around 160. With the environment done, I move on to fixing the player. First thing you're going to notice is that the doll is now stuck in the swinging animation, and that's because Godot 4 now removes the loop suffixes from animation names, so the blend spaces are all messed up. And also, the number of inputs on my transition node is somewhat back to 0, with the first input name changed to something else. To fix them, I go into the animation state tree, set the number of inputs back to 5, rename the first one to on ground, reconnect the transition to the output to refresh the UI, and reconnect all blend spaces to appropriate slots. Next, I go into each blend space and set the appropriate animations on all of the points that have looping animations. And now all of the animations are playing correctly. Next, I fix the collision shape of the player by clearing its rotation and setting its height to 1.8 meters. Next, I go into the dash VFX and set its emission shape to a box that fits the player body, and set the minimum and maximum velocities of the surge VFX to 1 and 3 respectively. With the player scene done, I move on to fixing the UI elements. For that, I first go into the virtual button and virtual thumbstick scenes and enable ignore texture size for each of the texture elements, and also make sure to set the custom minimum size of the virtual button to 64 by 64. Next, I go into the virtual button script, remove duplicate type hints, clean up to-dos, fix the setters, and move the class name statement to the top. With that, the buttons now have their properties back, but they're too close to each other because the containers have lost their custom separation values. So to fix that, I set the custom separation value of the VBox container to 32 pixels, and for the HBox container I set it to 128 pixels. Now you can also notice that the textures have jagged edges, and to fix that I re-import all of them with mipmaps enabled, and I set the texture filter of the root mobile controls node to linear mipmap anisotropic. I can now proceed to fixing the compilation and runtime errors. First, I remove the duplicate type hints in the export statements that were generated by Godot during the conversion process, and then I go to the root state script and make sure to assign the state machine property in the ready method. Then I go into the state machine script, move the class name statement to the top, and remove the unnecessary type hint from the initial state field. Next, I go into the virtual thumbstick script and give explicit types to the row drag vec and row length variables in the update drag function. It's a good time to reload the project now to get rid of some errors, so I do that. I still have some errors in the output though, and that's because the velocity field in the player script now conflicts with the built-in velocity field of the character body 3D class. I originally used the velocity field to refer to the horizontal velocity, so I renamed mine to horizontal velocity and use that in the physics process method to calculate the velocity and also get rid of the real velocity field. Next, I remove the unnecessary setters before the move and slide calls which were generated by Godot, because now the arguments to the move and slide methods are replaced with properties that you can set on character 3 body 3D nodes. Next, I go into the controllable camera script and replace rotation degrees with rotation while making sure to call deg to rad function on the rot h and rot v values. I then go through all lerp calls and make sure to call lerp f for float values, otherwise I would encounter null value errors, and I also replace the .lerp method calls on class instances with the global lerp function. Now I can launch the game, and when I do, you're going to notice that I forgot to hide the mobile controls UI. The game screen is a bit too small and I'm unable to move. To fix that, I hide the mobile controls node, go into the project settings, set the window size to 1366 by 768 and the stretch mode to viewport, and I reassign the key mappings for each action. Now when I relaunch the game, I realize I still can't move because I forgot to replace the appropriate velocity assignments with the new horizontal velocity field. And with that done, I can now jump and move around, swim, dash and surge. But jumping and dashing doesn't always work, despite the fact that my cooldowns and jump counts are okay, and both of these issues are caused by premature state transitions. So to fix the jumping issue, I go into the in-air script and remove the else handle from the process method, and to fix dashing, I create an empty process in the dashing script. And now everything works as expected. I'm practically done now, but I still do a final stylistic change by replacing the callable calls with actual method references for each of my signal connections. And that's it for the migration. It wasn't as bad as I thought, and it was actually much more smoother than my experience in alpha versions. And although I didn't get to test it on my Android device because the welcome version on the device is not compatible with the one shipped by Godot 4, I am quite happy with how Godot 4 works now, and I actually decided to target Godot 4 in all of my future videos. As always, you can find links to the code in the description box below, and thanks for watching.